So welcome back to Made Easy Academia. So now we have already discussed about addition of complex numbers, subtraction of complex numbers. At the same time, talk about multiplication of complex numbers. So now let's take a look at division of our complex numbers. So recall, in our previous example, we mentioned how we can find conjugate of a complex number. I told you, for example, if I have something like 1 plus 2i, that means conjugate is going to be what? It's going to be 1 minus 2i. So now, using that, we'll be using that one under this division of our complex number. I can just like the way we normally rationalize sort. For example, let's say they said division of complex number. Division of complex number. So let's take a look at some example. He said evaluate the following. Following in the form of a plus bi. That is, one should be for real numbers, at the same time one should be for imaginary numbers. So one, let's say we have 2 over 1 plus i. 1 plus i. Go 2. Let's say we have 2 plus I over 1 plus I. Go 3. Let's say we have 3 plus I over 2 minus I. So let's take a look at these 3 examples. I'll follow the same patterns, the same logic of how we can approach the first one, the second one, as well the third one. So in the first example, what we are asked to find, they said we should find the value of this 1 plus I. Just like we do what we call division, because the number is form of division, just like the way we normally rationalize sort. So now, if you look at this value, you see what we have there is 2 over 1 plus I, meaning the conjugate of this is going to be what? Exactly, it's going to be 1 minus I. So that value, I will use to multiply numerator. At the same time, I will use to multiply denominator. So meaning this will become 2 over 1 plus I multiplied by 1 minus I over 1 minus I. Remember, as I mentioned in the previous video, that this complex number is comprises of the real numbers, at the same time the imaginary numbers. So now, what we are asked to evaluate is 2 over 1 plus I. So meaning the conjugate of this, just like I want to rationalize it, so the conjugate of this, we have it to be 1 minus I. So meaning this one is going to become 2 over 1 plus I multiplied by the conjugate of this is going to be 1 minus I. So that's why we have 1 minus I over 1 minus I. I hope you are following. Yeah, good. Now, meaning numerator will multiply numerator, at the same time denominator will multiply denominator. So that means this one can be 2 bracket over 1 minus I divided by what we have here is 1 plus I and 1 minus I. You can see what we are trying to do. I will multiply 2 by 1 and I will multiply 1 plus I together with 1 minus I. We are just analyzing. That's why we call it division of our complex numbers. So let me open the bracket of this. So 2 multiplied by 1, of course, we are going to have 2. So this is minus 2 multiplied by I, we are going to have 2I divided by now. No, I told you, I've already taught you how to expand the simple terms. Just follow the same logic here. And don't forget that when we have I square is equivalent to what? Yeah, it's equivalent to minus 1. So now, 1 times 1 here, we have that one to be 1. 1 times minus I, that's going to be minus I. Plus I times 1, that's going to be plus I. Now, plus times minus, that's going to be minus. I times I, that's going to be I squared. You just follow the same pattern. The first one here, multiply these 2. The second one here, to also multiply the 2. That is 1 times 1, we have it to be 1. 1 times minus I, we have it to be minus I. Plus I times 1, and we have it to be plus I. Plus I times minus I, that is plus times minus, we are going to have it to be minus, then I times I, we are going to have it to be I squared. So here, I can have this one to be 2 minus 2I divided by 1. You can see what I have here is minus I, and what I have here is plus I. So minus I plus I, that's going to be 0. Then we have minus I squared. So recall, if I have I squared, as I told you from the beginning of this complex number class, that whenever we have I squared is nothing but minus 1. So I can just substitute it here. So this one can just become 2 minus 2I divided by 1 minus. So instead of writing I squared, we know that I squared is minus 1, right? Yeah, so let's substitute. That means that we have minus 1. So here we are going to have 2 minus 2I divided by, if I have minus, we call the way we normally choose the sign. You don't forget that. But that one is very, very important. Even if it's not this topic, choosing sign, how to get when we have minus times minus, or when we have plus times minus, or when we have minus times plus, or plus times minus. That one too is very, very important in mathematics. So here now, if I have minus minus now, that's going to be what? Exactly, that's going to be plus, because what we have here is minus, and what we have here is also minus. So minus times minus, that's going to be plus. That's plus 1. So here we have 2 minus 2I divided by 1 plus 1. Of course, we are going to have 2. So, but recall, they said we should leave our answer in the form of A plus IB. That is, meaning we should separate the real numbers and we should separate the imaginary numbers. So we can go further by saying this is nothing but, if I use these two to define them one after the other, this is nothing but 2 over 2 minus 2I over 2. Isn't it? That is just like with split fraction. If I have something like AX plus BY plus C over D, for example, I can use this D to divide the term one after the other. Meaning, this can be AX over D, the first one. Second one, BX over D. The third one, C over D. So that's what you are trying to do here. So I want to use these two to define the first term as well, to define the second term. So now I will have this one to be 2 over 2. That's going to be 1 minus 2 into we are going to have 1. Then we are going to have I. So assuming you can see now we have already split the numbers in form of real numbers at the same time imaginary. Let's say we are asked to find A and B. If they specify, by comparison, you can easily find our A here and our B here as well. So A here is going to be 1 and our B is going to be minus 1, which is the coefficient of what? Coefficient of I. That's how we normally have rationalize a complex number, just like rationalization in sort. When we have the numbers, if it is a positive, take a conjugate, it is going to be negative. If it is negative, take a conjugate, which is going to be positive. Let's take a look at the second example. They say we have, in the second example, they say we have 2 plus I over 1 plus I. You can see the only difference between them is, in the first one, we only have numbers here. But here you can see both numerator and denominator, there are 2. I have real numbers, imaginary numbers, real numbers, at the same time, imaginary. It doesn't matter. We are going to follow it, the same process. So what is going to be the conjugate of this? Yes, exactly. It's going to be 1 minus I. So we use that one to multiply numerator at the same time denominator. That is, the conjugate of this is 1 minus I. So now, meaning this one can be 2 plus I over 1 plus I. So the conjugate of this is 1 minus I, right? So that's going to be multiplied by 1 minus I over 1 minus I. So now, the next thing now is to multiply numerator by numerator. At the same time, denominator by denominator. So we can see, so please take note of this one. It's just like a simple expansion. That is, taking the first term for the first term here, the first term here for the second term, they as well go to the second term here, the second term for the first one, the second term for the second term as well. Just like the way we are going to expand numerator with the same as the way we are going to expand the denominator. So this one, we can have this one to be 2 plus I 1 minus I, that's for the denominator. Then here we have here is 1 plus I, at the same time 1 minus I. Just a simple expansion. Multiply the first one by this first one, second one by the second one. So here I can have this to be 2 times 1, that's going to be 2, right? 2 multiplied by minus I, that's going to be minus 2I. plus I times 1, and we have plus I. So plus times minus, that's going to be minus. I times I, that's going to be I squared divided by, so now this one, to let's expand it, just like the way we expand denominator. 1 times 1, and we have that one to be 1. 1 times minus I, and we have that one to be minus I, plus I times 1, that's going to be what? Exactly, that's going to be plus I. Then the last term, plus times minus, that one is minus, then I times I, and we have it as a I squared. So now the next one now is just for me to evaluate the terms. So here I can have this one to be 2 minus 2I plus I. It's just like minus 2 plus 1, just like a simple arithmetic. So minus 2I plus I, that's going to be what? Yes, exactly. That's going to be minus I, just like I. So minus I squared. Recall that we have, whenever we have I squared is a minus 1. So I can have this one to be minus 1 divided by, so let's go for the denominator to 1 minus I plus I, that's 0. Then minus I squared as well is a minus 1. So now I can have this one to be 2 minus I. You can see this is minus, this is also minus. So minus times minus, we are going to have a plus. So now 1 times 1, and we have 1, all divided by 1 minus times minus as well, and we have plus. Then we have 1 here. So now if I had this you can see this is real numbers. At the same time, this is real numbers. I can only add. Don't forget, I told you in the previous slide that whenever we have complex numbers, we can only add real number for the real numbers. At the same time, imaginary number for imaginary number. Don't be saying, for example, let's say I have 3 plus I. Can we have 3 I? So please, you can see this is real numbers, this is imaginary. Under the complex numbers, the real number, we go for the real numbers. At the same time, the imaginary number will go for imaginary numbers. So now, if I take this, so now you count, if I take this 2 plus 1, that's going to be 3 minus I divided by 1 plus 1, and we have 2. So now, since I want to split it in the form of A plus IB, that is the real part and imaginary part, so I can have this one to be 3 over 2, then minus 1 over 2I. You can see we have already split that term now. These are our real numbers, and this is our imaginary numbers. So even in the third example as well, you can see what we have there is 3 plus I. I hope you can find that one as simple exercises. So we have 3 plus I over 2 minus I. Just like we are going to, what's going to be conjugate of this? Yes, the other is going to be 2 plus I, then 2 plus I. You just follow the same process. Using this one to expand this, using this to expand this as well, then you get your time and simplify the two into real numbers. At the same time, let's take a look at a question from past questions. We have a question here. The question says that the question says write 3 minus I over 1 plus I in the form of A plus IB. Now you can see this one too, they are only asking us to simplify the terms, that is the real part, at the same time the imaginary numbers. So now I will follow the same process. So what I have is 3 minus I, 1 plus I. So I will go the same logic using this, taking the conjugate of this. That's going to be what? That's going to be minus. That's 1 multiplied by 1 minus I, 1 minus I. So now I will use the first time here to multiply this. To make it easier, I can introduce the bracket. 3 minus I, that's for the first one, then 1 minus I for the second one, isn't it? Then the one we have here, that's 1 plus I, at the same time 1 minus I. So let's take a look at simple expansion. 3 times 1, that's going to be 3. That's the first one. 3 times minus I, that's going to be 3I, minus I times 1, that's going to be 1I, and 1I is the same thing as I. Then minus times minus, that one is plus. I times I will have it as a I squared, all divided by, so this one too, 1 times 1, that's going to be 1. 1 times minus I, that's going to be minus I, plus I times 1, that's going to be plus I. Then plus times minus, that's going to be minus I times I, we are going to have I squared. You can see just a simple logic, it's simple arithmetic. Using the first one to multiply the first one as well to multiply the second one, just a simple expansion. So now here I can have this one to be 3 minus 3I minus I. Just like a simple addition now. I'm adding the two terms together. That's going to be minus 4I. So don't forget, if you have I squared, is nothing but minus 1. Yeah. So divided by 1. So minus I plus I. That's going to be 0. Then minus I squared is what? Yes, exactly. I squared is you can see I'm using the previous one to determine this. Do not forget that I squared is minus 1. Square root of minus 1 is I. You have to be know how, I told you in the previous class, in the previous beginning of this class, that whenever we have like I4, I10, the only thing necessary for you to do is to know your I squared. Then we'll be playing with powers, the exponential. Like if you say I to find I10, for example, that one is just like I squared, I2, I raised to the power of 2, I raised to the power of 2, like 5 times. Then since I know the I squared, that I squared is minus 1, I will just be plugging the values one after the other. So the same logic here applicable to whenever we see I and I squared. So now, so here we can have this to be 3 minus 4I. So plus times minus, that's going to be minus 1, all divided by 1. So minus times minus of this, and we have plus 1. Now, so here, so let's add real number for the real numbers. Then we have 3 minus 1. That's going to be 2 minus 4I divided by 1 plus 1, and we have 2. As I told you, these two divide the first numbers and we also divide the second number, meaning this implies means 2 over 2 minus 4I over 2. So now 2 over 2, and we have 1. Then this one can just give us a 2I. You can see. So our real number here is going to be 1, and our imaginary number here is going to be minus what? Minus 2. That's all about the division, which is a rationalization of complex numbers. So now the next thing that we have on the agenda is how can we represent this complex number in Agar diagram? We call it Agar diagram. How can we represent both the real numbers and imaginary number in Agar diagram? That is, the two can be represented in Agar diagram. Just like what we have in secondary school. That when we have plane, we have what normally we have what we call, sorry about that, we have what we call the y-axis. At the same time, we have what we call x-axis. Now, in this case also, I will be using this logic. That is, we are going to have, but it's just like when we are plotting quadratic graph. That is, we are going to have the positive side, at the same time the negative for y. As well, we are going to have the positive x, at the same time we are going to have the negative x. So now, if I have a plane like this, is what we know that this side is what we call the vertical, and this is what we call horizontal. So please, in this case, whenever we have, if you want to plot, let's say I have a plus ib, for example. I know this is real numbers, this is imaginary. If I want to draw another diagram, in any cases, the vertical is always for the imaginary, then the horizontal is always for the real. So now what now left is it positive real numbers? Is it negative real numbers? Is it positive imaginary numbers, or is it negative imaginary? So I will clearly show you now how to represent them in Agar diagram using that. For example, let's say we have something like this. Look at this one. If I have something like this, you can see I divide them into 4. Let me label them. Let's say this is positive y. Sure. This is negative y. This is positive x. And this is a negative x. Now, you see, if the value, I told you this is for positive imaginary numbers. This is for negative imaginary numbers. Now, this is for positive real numbers. This is for negative real numbers. Now you can see, meaning if I'm solving a problem, what I will check, that number given to me to represent in the Aga diagram, is it positive? Is it negative? If it is positive imaginary number, you put it here. If it is a negative imaginary number, it's going to be here. If it is positive real numbers, we are going to assign it here. And if it is negative real number, we put it here. How? Let's say, for example, I want to put A plus IB. You can see these two are positive. Here, the real number is positive. At the same time, the imaginary number 2 is also positive. So I can just say, this is my B here, and this is my A. So I can form the right angle triangle from A. And here too, you'll be asked to find the modulus. How do you normally find the modulus? You just take the square root of imaginary number together with the real number. For example, if I want to find the modulus of this, I can let it represent it by R. I can say this is nothing but A square plus B square. Just take the square root of the real numbers at the same time the imaginary. Let's see how we can play with this. Let me bring like three values. Let's say I want to represent this value in the plane diagram. Let's say we have 5 plus 6i. So clearly here you can see this 5 is positive, right? This 6 also is also positive. So that means since they are positive, I will deal with this because this side is for positive imaginary numbers. This one is for positive real numbers. So I can draw it like this so that for them to know that I know what I'm doing. This is positive imaginary numbers, positive real numbers. So what I have for the imaginary number is 6. What I have for this one is 5. So here you can have the diagram like this. I can represent one as R, and I can find the modulus. Even in some cases, you may be asked to find the argument. So please take note of that. Whenever you call argument, it's just theta, the angle that we have here. You know, if I have a right angle triangle, it's another thing. If I have a right angle triangle, I can find its argument. I can find its theta. You know, where the angle face is called what? Exactly. It's called the opposite. What we have here is adjacent, and what we have here is hypotenuse. You remember the formula for the SOHCAHTOA? We have SOHCAHTOA, that is, we have sine theta, we have cos theta, at the same time we have tan theta. You know, from SOHCAHTOA, the one we learned in junior secondary school, SOHCAHTOA. It's just an acronym. So if I have sine, I can say sine theta is equal to opposite over hypotenuse. If I have cos, that one can be adjacent over hypotenuse. If I have tan, that one is opposite over adjacent. So now, whenever I have this, so it depends. I can use any of these three, depending on the problem I'm solving, to find my argument, which is theta. I can use sine, I can use cos, at the same time, we can use sine. We can use tan. So now, look at this problem. I represent this value on it. So with this, let's say they change the value. Let's say what we have is 5. Let's say we have 5 minus 6i, for example. You can see. So in this number now, you can see the real numbers remain as positive, but now the imaginary number become negative. That means this diagram will change. So how is it going to change? You can leave the real number like this, then you change the imaginary numbers. How are we going to change that? You can see now it's going to be here because we said this side is for positive imaginary numbers, this side is for negative imaginary numbers, right? So that's going to be that value, which is so you can see anyhow we put it there, either in the first place or in the second. It depends on how we have the values. Assuming now, if the real number is negative here, we can put it here. Can be, let's say the number we have is, let's say, is minus 2 or whatever we have there. You can just put it here. So it depends on what we have the value. So when we are doing the Aga diagram, we consider the factors that we have for that particular the real numbers. Is the real number, is it positive? Is it imaginary number? Is it positive or negative? So when we have it, we determine where we are going to put it in this Aga diagram. So now you can find the modulus of that. You can find the modulus. You can find the argument. I told you, whenever you have to find the argument, they are just talking about the theta, the angle theta. You can use sine, you can use cos, or you can use tan. So for example, let's take a look at this problem. Let's say we have let's say they said, draw a angle diagram for let's say z is equal to 3 plus 4i, hence find its modulus and argument. Maybe we ask argument of z. I told you argument of z is nothing but to find the angle theta. So if you look at these two values, we can see the two of them, they are both positive, isn't it? You can see this is positive, at the same time, this is also positive. So now let's see how we can draw that. This is positive imaginary numbers, negative imaginary numbers, positive real numbers, negative real numbers. So now I have the real number to be 3. I have 3 here. I have the imaginary number to be 4. You can see I put in the first point here. I know the rotation of the angles. That one is important. We normally rotate an angle clockwise. This is 90 degree. 90 plus 90, that's going to be 180 plus 90, that's going to be 270 plus 90, that's going to be 360. So that one is important because where you have the values will determine where you're going to subtract or add your argument on. So now, we are lucky here, the value that we have is in the first quadrant. And in the first quadrant, using the knowledge of all science take chemistry. Do you get the logic of that? All science take chemistry, all science take chemistry. I give you this one as just like a T. Just a simple logic of how you can recognize the quadrant. In the first quadrant, all are positive, meaning sine is positive, cos is positive, and tan is also positive. In the second quadrant, only sine, you can see S, only sine is positive. Now in the third quadrant, take, that is only tan. This is the first quadrant. We are reading it anticlockwise. Second, third, and fourth. So in the first one here, all are positive. That is, sine is positive, cos is positive as well. Then tan is also positive. So under the second quadrant, only sine is positive. Meaning, if I'm solving a problem, if I reach this quadrant, only sine will be positive here. Now, so in the third one we have take. You can see what that take is t. Meaning, in the third quadrant, only tan is positive, which means the sine will be negative as well. The cos will be negative. Now, in the last quadrant, chemistry, that is C, which means only cos here will be what? Only cos will be positive. You can see instead of you cramming it, you don't need to cram it. That's why you have it, or you have us here. You can just use these acronyms. All science take chemistry. Meaning, in the first quadrant, all are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. In the last quadrant, only cos is you don't need to cram anything here. Mathematics is just the study of counting. It's simple and straightforward to perform its operations. So now, let's go back to our problem we are solving. So since we have the both numbers as positive, that means the imaginary number is 4, the real number is 3. So I can find my modulus here. What I told you, modulus is nothing but finding the square root of both the real numbers and the imaginary. I can have out here to be square root of what I have here is z, which is 3 plus 4i. So meaning that's going to be 3 square plus 4 square. So we are going to have r to be equal to square root of 3 square is 9, 4 square is 16. So this one can give us a square root of 25. And we know the square root of 25 is going to give us 5. So meaning our modulus here is equal to 5. So let me just show you how to find the argument. I told you arguments imply means z. You can use sine, you can use cos, you can use tan. I will use the 3 so that you press the calculator for me to confirm if the result is the same. Now, if I bring out the shape now, it looks like a right angle triangle. We have something like this. I have theta here, we have 4 here, we have 3 here, we have 5 here. Recall, if I want to use sine, sine is opposite over hypotenuse here. Now, our opposite here is 4. Our hypotenuse here is 5, right? So now I can have sine theta now is equal to 4 over 5. If you divide 4 over 5, I think you are going to have 0.8. So I will leave one exercise for you now to do. You just help me to press the sine inverse and confirm if the three results is going to be the same. So here I can have theta to be sine inverse over 0.8. So whatever you get for the sine inverse of 0.8, so now I will still check for the cos or for the tan. If I want to use tan, tan is nothing but opposite over adjacent. So now I can have tan theta is equal, from this shape, these are opposite, these are our adjacent, and these are our hypotenuse. So now opposite is 4, adjacent is 3. So if you define this one, I think we are going to have 1.3333. Then you find the tan inverse of this. You see the result of this one, or if you leave it as fractions, the result of this will be the same thing as when you look for the value of sine inverse of 0.8. At least I want you to do a little exercise so that you can confirm the result that they're going to be the same. So if you wish, you can use cos as well. When we have cos is nothing but adjacent over hypotenuse. So now I can have this one to be cos is equal to the adjacent that we have here is 3. Then over hypotenuse we have there is 5. Then you define this one. I think if you define the 0.3 over 5, that's going to be 0.6. Then you find the inverse of this one. So please confirm these three results. That are they going to be the same? If you check cos inverse of 0.6, if I check sine inverse of 0.8, or I check tan inverse of 4 over 3, if you check all the three values, you see that we have the same answer. That is, the theta will be the same. That one is a simple exercise for you to do, please. Now, so at the same time, when we have the theta now, is what we call the argument. Argument simply means the theta, the angle between the real numbers as well and the imaginary numbers. So you can follow the same process. If you are putting it here, I've already given you the clue of all science take chemistry. If it is here, to save our time, if it is here, you know how to find that. If it is here, you know how to rotate the angle. Angle from here to here is 90. This is 180. This is 270. At the same time, these are 360.